Okay, hello guys. Uh, Today in this lecture I am going to explain the rest of the concepts that are related to arithmetic. So I will start by explaining the concept of exponents. Okay, so let's start by talking about exponents. And how can we calculate the value of an exponent? Okay, what do we mean by an exponent? When we say we have a mathematical expression called exponent, what do we mean by it? An exponent basically is a mathematical expression that has this form: a, okay, raised to the power b, where a and b are numbers, any real numbers. So if we have any two numbers, okay, written in this form, then this form is called a mathematical exponent. All right. Now, okay, we call a as the base of the exponent. So this is the base of the exponent, and b is called the power or exponent, or the exponent itself. So the power of the exponent a to the power b is b, and a is called the base of this component, of this exponent, sorry. Okay. Now, what is the definition of the exponent, or how can we calculate the value of a specific mathematical exponent? Okay. A raised to the power b is defined as the multiplication of the base a by itself b times. So if we have an exponent a raised to the power b, then this exponent is going to have the value of a, which is the base, multiplied by itself, okay, b times. All right, so this is here b times. Okay, I'm going to give you an example of how we can calculate the values of different types of exponents. Now, suppose that we have an exponent, for example, 3 raised to the power 2. So this is equal to 3 multiplied by itself 2 times. So this will give us the value of 9. This will give us the value of 9. So 3 raised to the power 2 is called will give us 9. Okay. Now, if we have another example, just to give you more sense of how we can calculate the value of an exponent. Suppose that we have, for example, minus 2. Okay, by the way, the base of an exponent could have, okay, the base or the power. The base or the power can be either positive or negative. So in this example, I am having the base as a negative number. So we have the base of minus 2, and this base is being raised to the power, for example, 3. So how can we calculate the value of this exponent? According to the definition, I am going to multiply minus 2, which is the base of the exponent, by itself 3 times. 3 times. So this will give us the value of what? Minus 2 multiplied by minus 2 will give us 4. 4 multiplied by minus 2 is going to give us minus 8. Alright. Okay, so this is how we calculate the value of a mathematical exponent. Okay, now we would like to, you need to know that if you have an exponent where the power is equal to 2, then this operation, this mathematical operation is called squaring. All right, squaring. So when you hear the word squaring, this means that we have an exponent where the base is actually raised to the power of 2. Okay, so I am multiplying the value of the base by itself 2 times. This is the definition of the squaring. Okay, the squaring operation. All right. Okay, according to these two examples, as you can see, the result that we obtain from the calculation of exponents might be positive, like in this example, or negative, like in this example. So we may obtain the value. The value of an exponent might be either positive or negative, like here. Okay? So when can we expect, now the question is, when can we expect to obtain a positive or a negative number when we deal with exponents? Okay, all right, suppose that we have, okay, that we have a positive, okay, suppose that we have a positive number, a positive or a negative number. So this is equal to minus 2, for example, minus 2 raised to the power 2. Okay, raised to the power 2. How can we calculate the value of this exponent? So in this case, I have to multiply the value of minus 2 by itself. How many times? 2 times. So this will give us what? This will give us the value of 4. So in this case, I am getting a positive result or a positive value. Okay, so this is a rule. When we have a negative base, so if you have a negative base that is raised to an even power, like 2 in this case, then we are expecting to get a positive value, or the exponent that I am calculating is going to have a positive value. Okay, so if you have a negative base raised to an even power, then the value of this component should be positive. Okay, however, if I am raising a negative base to the power, to an odd power like 3, okay, so I am raising a negative base to the power of 3, which is an odd number, then we are expecting to get actually an odd value. So we have to multiply minus 2 by itself 3 times, which is going to give us what? The value of minus 8, as what we did here in this example. So if a negative number is raised to an odd power, then the value of this exponent is what? Is negative. All right. However, if a negative base is raised to an even number, then the value of this exponent is always positive. Okay? Okay, what else do we need to know about exponents? One important thing that we need to know about exponents is the following. All right. Suppose that we have an exponent where the power is actually negative. All right. So suppose that we have, for example, a, which is the base of an exponent, and this base is being raised to a negative number, which is, for example, minus 1. How can we calculate this value? Okay, how can we calculate this value? In this case, this exponent is equal to the reciprocal of a raised to the positive power, raised to the power 1. So in this case, this is equal to what? 1 divided by a. Okay, another example, if a is raised to the power minus 2, which is a negative number, then I have to what? To reverse. I have to calculate the reciprocal of a to the power minus 2, which is 1 divided by a squared. This is 1 divided by a squared. Okay, all right. The same thing, a raised to the power minus 3, this is equal to 1 divided by a cubed. Okay, one important thing that we need to know, for example, if I multiply, so if we have two exponents, if we have two mathematical exponents that are multiplied by each other, then the result is going to be what? How can we calculate, how can we deal with the multiplication of two exponents? Okay, suppose that we have two exponents having the same base, and these exponents are being multiplied by each other. So we have a to the power b multiplied by a to the power c. So if the two exponents, the rule is, if the two exponents that I am multiplying have the same base, then the result of the multiplication is going to be an exponent having the same base raised to the power, which is the summation of the powers of the two corresponding, of the two multiplied exponents. So A is going to be raised to the power of B plus C. All right, B plus C. This is unimportant. But this again, this rule only applies when the two exponents that I am multiplying are having the same base. Okay, how about this is multiplying, the multiplication. How about the division? How can we deal with the division? So if we have two exponents, A raised to the power B divided by A raised to the power C, so these are two exponents that have the same base. So the result is going to be an exponent which has the same base A, but at the same base A, and this base is being raised to the power of B, which is the power of the exponent in the numerator minus the power of the exponent in the denominator. So B minus C. Alright, this is how can we calculate the values, or how we can deal with the multiplication and division of two different exponents. If the two exponents that I am multiplying have different bases, then we cannot apply this rule. This is an important note that you should always keep in mind when you deal with the multiplication or division of two exponents. Okay, all right, now, okay, just to make use of the time, I am going to move to explaining a different concept, which is the roots. All right, what do we mean by the roots? Okay, so we have something called roots. What do we mean by the roots? Mathematical roots. Okay, all right, we have something called the square root. What is the square root of a number? The square, okay, sorry, I'm using the mouse for the writing, that's why the writing is not actually good. So we have something called the square root. Suppose that we have a number, for example, a number A, and we would like, okay, we would like to calculate the square root of this number A. First of all, the square root is actually denoted by the symbol this. Okay, this is when we see this symbol, then we should expect ourselves to be dealing with square roots. Okay, and the number which we are calculating the square root of is always written under this symbol. So let's say that we have, for example, the square root of A. All right, what do we mean by, or how can we define the square root of a number A? The square root of a number A. The square root of a number A is actually a number R. Let's denote the result of the square root is R. Now, the square root of A, let's suppose that the square root of A will give us the value of R. What will be the value of R? So in this case, R is actually, okay, so if we multiply the value of R by itself 2 times, this will give us the value of A. Okay, so this is actually the definition of the square root. From this definition, we can expect, or we can understand the square root of a number to be, okay, to be the reversing of the squaring operation. The reversing of the squaring operation. So if we have, for example, R squared, okay, according to the definition that we have previously mentioned, the squaring of a base R is defined as the multiplication of the base R by itself 2 times. Okay, so this is R multiplied by itself 2 times. All right, okay, this will give us actually the value of a. So this is how you can understand the square root of a. Okay, so if r multiplied by r gives us the value of a, we say that the square root of a is equal to r. So it is actually the reverse, okay, the reversing of the squaring operation. All right, the square root of a. Let's actually give another example of how we can calculate the square root of a specific number. Let's say that we have, for example, the square root of 4. The square root of 4. Okay, what will be, or what is the value that if I raise to the power of 2, will give us the value of 4? What is the number that if I raise to the power of 2 is going to give us the value of 4? Of course, the answer of this question is 2. Okay, because if I multiply 2 by itself 2 times, okay, 2 times, this will give us the value of what? Of 4. Okay, the question now is 2 the only possible number that if squared will give us the value of 4? Is there any other number that will, okay, give us the value of 4 if that number is squared by 2? Yes. What is that other possible number? Is actually the negative of 2. Also, the negative of 2, if the negative of 2 is multiplied by itself 2 times, or if squared, this will give us the same value of 4. So here is one important rule. If you are calculating the square root of an even number, okay, an even number, then the result of the square root is going to have two values, one positive and one negative. Okay, so for an even numbers, you have two values. One is positive. For an even numbers, the square root of an even number is going to give you two values. One of them is positive and the other is negative. Okay, one example is the square root of 16. So 16 is an even number for which I am calculating the square root. So this will give us the value of 4 and actually minus 4 as well. So minus 4 also is one of the square roots of 16. All right. Okay. So this is the square root. Now I am going to move on to the definition of something called the cube root. Okay, what is the cube root? All right. Okay, so I am going to now provide you with the definition of a cube root. First of all, the symbol that we are using to denote the cube root of a specific number is actually the same symbol, but we have to put the value of a 3 here. Okay, so when we see this symbol, then you are working on calculating the cube root of the value which is written under here. Okay, the cube root. Okay, so let's say, okay, I will give you an example of how we can calculate the cube root of a specific number. Suppose that we have the cube root of 27. All right, of 27. All right. So according to the definition, the same definition that we have given to the square root also applies to the cube root. So if we are calculating the cube root of a number, we should ask ourselves the following question: what is the value or the number that if we multiply by itself 3 times will give us the value of 27? Okay, 27 is actually the value of a 3, right? So if you multiply a 3 by itself 3 times, 3 multiplied by 3 multiplied by 3, this will give you the value of what? Of a 27, right? Is there any other number? No. Okay. Actually, okay, is the negative, okay, can the negative of a 3 also be the cubic root of a 27? No, because if we multiply the value of minus 3 by itself 3 times, okay, 3 times, this will give us what? This will give us actually minus 27. It won't give us the value of a 27 which is under the cubic root. So in this case we have another rule, okay, another rule that we should keep in mind when we deal with the roots. If the number for which we are calculating the cubic root is negative, all right, is negative, then we are going to get only one value for the cubic root, one value, which is in our case here is a 3. Okay, how about, okay, how about the cubic root of 46? 46. So what is the number that if we multiply by itself 3 times will give us the value of 64? Of course the number is 4. So 4 multiplied by 4 multiplied by 4 will give us the value of 63. So this is how we calculate the cubic root of a specific number. Okay, this is an important rule. Okay, what else, or what are the other rules that we should keep in mind when we deal with roots? Okay, I'm going to give you some important rules, all right, about roots. Okay, suppose that we would like to calculate the multiplication of two square roots. Okay, suppose that we have this example, the square root of a multiplied by the square root of b. The square root of b. Okay, this is equal to what? So the rule says that if we have two square roots multiplied by each other, the result of this multiplication is going to be the square root of the multiplication of the two numbers under the two corresponding roots. So this is a multiplied by b. All right, this is how we can calculate the multiplication of two square roots. Okay, the same thing applies if we would like to calculate the multiplication of two cubic roots. Then the result is going to be the cubic root of the multiplication of the two numbers. All right, this is also an important. Okay, what about if we have the square root of a divided by the square root of b? So in this case, the result is going to be the square root of a divided by b. Okay, the square root of a divided by b. All right. Okay, one other rule that you need to keep in mind as well is that if you are calculating the root of the square root of a, the square root of a is also, or can also be written in the form of a raised to the power half. Okay, raised to the power half. This is an important note. So the square root of a specific number can be also written in the form of an exponent where the base of that exponent is a and the power of that exponent is 1 divided by 2. Okay, how about the cube root of a? Is there another way of writing the cube root of a specific number? Yes. This is equal to an exponent where the base is a raised to the power 1 divided by 3. So if we would like to okay, if we would like to write a general rule where we are calculating the root of a, the nth root, okay, the nth root, this is equal to what? This is equal to an exponent where the base is a raised to the power 1 divided by n. All right, this is an important note as well. All right, so this is actually all what you need to know about roots. Okay, now I'm going to talk about something called the real numbers. The real numbers. Okay. So the real numbers, let's say, all right, what is the real numbers? So we have the concept of real numbers. The real numbers. Actually, the real numbers is the set of mathematical numbers which is denoted by the symbol r. So if you have, okay, if you ever see this this letter is actually used to represent the whole set of real numbers, okay, is denoted by r. Okay, what is the real numbers? The real number is, okay, the real numbers is the whole set of numbers. So, okay, so let's say that we would like to represent the whole set of real numbers in the form of this line. So suppose that we have this line, all right, we have this line. This line is called the line number, the line number, and is actually, sorry about the writing. So we have the line number. This is a graphical method that is used to represent the whole set of real numbers. Now, the value which is placed in the midpoint of this line is actually 0. So we have the value of 0, which is also a member of the set of real numbers. So 0 is considered to be a real number. Okay. Now, all the positive numbers that you can think of that are greater than 0, whether it is positive, okay, whether it is rational numbers,